Good evening, teacher. My name is Yew Jieh. In this presentation, I will be walking through my software engineering evaluation of WhatsApp. WhatsApp is a global messaging application founded in 2009 by Jane Cohn and Brian Acton, later acquired by Facebook, which is called Meta right now, in 2014. It's used by billions of people worldwide. Its code has always been simple: fast, convenient, low-cost communication over the internet, replacing the traditional SMS. Next. In this slide, we are going to talk about the process and methodology. Based on my analysis, WhatsApp wasn't built using the waterfall model. Waterfall follows a strict, fixed sequence, which is plan, design, code, test, and then release, without any going back. But WhatsApp history doesn't match that at all. It launched as a very small app with one goal, which is simple messaging. It was developed the feature incrementally over time by time. For example, photo sharing, Android support, voice message, web access, voice and video calls, and eventually end-to-end integration. This step-by-step growth pattern points to an interactive, incremental, and evolutionary is essentially agile style development model, which makes sense for a product that has to keep adapting to user needs and a fast-moving market. Next. In this slide, we are going to talk about the requirement. On the functional side, WhatsApp covers what users actually need day to day, which is registration, using just a phone number, free messaging over the internet, and the ability to share photos and documents, such as voice recording. On the non-functional side, three things stand out. First is performance. Message need to be developed and delivered almost instantly, even with huge numbers of concurrent users. Second is reliability. It's achieved through decentralized load balancing across multiple servers. A delivery acknowledgement system using the familiar single, double, and blue tick indicated, and store and forward for users who are temporarily offline. Third is security. Using end-to-end encryption protects user privacy. So overall, WhatsApp meets most user requirements as well. Dot is history of service outages and scanned accounts show there's still room for improvement. Next. In this slide, we are going to talk about the architecture. WhatsApp backend use a message passing, event-driven architecture built on the actor model, running on the Erlang bin virtual machine. Instead of handling every user connection as a heavy operating system thread, the way traditional systems like Java-based servers often do, each user is represented by a lightweight, isolated process. This gives WhatsApp low coupling through complete process isolation. There's no shared memory between processes, so if one crash, it doesn't affect anyone else. It's similarly to one waiter dropping a plate in a busy restaurant, while every other table keeps being served normally. The engineering team also went as far as customizing the underlying FreeBSD operating system network stack. It allowed a single server to handle over 2 million concurrent connections. On the design pattern side, they use the actor pattern for per user process and the flywheel pattern to keep memory usage minimal at massive scale. Next. For testing and quality, WhatsApp operates with a surprisingly small engineering team. So instead of large manual QA department, they rely on automated unit testing using Erlang's native framework. along with integration and load testing to simulate millions of concurrent connections before deployment. Their key strategy thought was a production-driven testing, rolling updates out to small fraction of servers first, monitoring live tele- telemetry like CPU usage and crash rates, and expanding gradually if things look stable. This approach gave them great engineering speed. However, it also introduced real quality gaps. For instance, the regressions affecting legacy devices like older BlackBerry phones and an inherent risk of using real production users as informal testers. Next, in this slide, we are going to talk about the evolution. Looking at long-term evolution through the lens of Lemma's law of software evolution, WhatsApp clearly demonstrates the law of continuing change, since it had to keep expanding as mobile platforms evolved and users' expectations shifted. It also shows a strong response to a law of increasing complexity. Rather than letting the codebase get messy as features pile up, the team prioritized regular refactoring and simplification in terms of managing technical debt. They contributed performance fix back to the open source Erlang OTP project, rewrote parts of the FreeBSD kernel instead of patching around its limits, and not template, integrated the Signal protocol for end-to-end encryption in 2014 without breaking the code architecture. The reason is the actor-based design kept routing logic separate from the encrypt payload. Next. In this slide, we are going to talk about the recommendation. So based on this analysis, I have three key recommendations. First, implement a proactive chaos engineering framework. Deliberately injecting network failure and process crash in a controlled way to validate resilience before real-world outage happen. Second, introducing an abstracted cryptography interface layer so that when the industry eventually moves towards quantum-resistant encryption, WhatsApp can swap up the cryptography module without having to rebuild the entire messaging pipeline. Third is adopt a data-driven, contract-based API with strict schema enforcement to prevent backend changes from breaking older app versions still used in regions with limited connectivity. Next, in summary, WhatsApp grew through an agile-style process rather than the waterfall model. Its actor model architecture with process acceleration enabled it to scale to billions of users. However, its lean production-driven testing approach carries real quality risks. Addressing this through chaos engineering, cryptography, flexibility, and stronger API contracts will help WhatsApp continue evolving sustainability. That's the end of my presentation. Thank you.